Hi, this is Jay from Coder House Tech Studio. I'm coming at you from the studio with part 2 in our series on bits and pieces you need in your Maker Studio. Part 1, which you can click on the clicky bits up in the corner, we talk about things like system on chips and microprocessors. Part 2, we're going to talk about inputs, outputs, and some architecture and design stuff. So with that, let's get to it. So we've already talked about the ESP32 as a communication board. Another board that we love to use is the Zigbee. This is a USB-based Zigbee, but they do have Zigbee hats like for the Arduinos and for Raspberry Pis and things like that. Zigbee is a wireless mesh network standard built for low cost, low power, and low data bandwidth. It's targeted to be used in battery-powered applications, which is super cool. And despite its low power, it's low latency as well. The Zigbee operates on the IEEE standard 802.15 and operates at 2.4 gigahertz. You may recognize the name Zigbee because these are often used in smart home applications like your Philips Hue lighting. In another video, we talked about displays like the XReal Air, which we absolutely love. And you can see that video here. Displays are super important to an application. Not necessarily all applications. We've had some where it was just something that sent data out into a network and collected by some other piece of equipment, like I said, like a Raspberry Pi for processing. But letting people know what's going on the device is always a good thing to do. I mean, there's lots of different displays that you can have. So you have multi-segment displays like these. You can have OLEDs. What I like about these OLEDs, these are really nice multi-colored displays. They come in just about any size and shape and everything. They have round ones and square ones and rectangle ones. You can also get these multi-line LCD displays as well if you just want something that's going to put the basic of information out. And you may have a multitude of these. So you may have the multi-line LED or LCD display along with an OLED, the OLED giving some other visual representation of what's going on with the device. And then sometimes we leave the display code in there and we leave the display hooked up. Sometimes the application calls for no display at all and we pull it out. But in any event, you need displays. And you can get displays for cheap on like Amazon and Alibaba. And just pick up packs and packs of different size displays and different types, different colors, and all of those things. Displays are good. Just as important as your output is your input. We recommend having lots of different types of inputs. So, you can have a little old school numeric keypad, which is good in some situations. Cameras are a form of input, right? So cameras are everywhere, and you may want to have those on there. Little joysticks. We love hooking up little joysticks to things to move around like a cursor on something, or if it has a nice OLED display, we can do almost like a video gamey kind of looking thing on it. You also have like sonar and other types of inputs. So just as important as your output is your input. And if you're going to need something from the physical world, whether it's moisture detectors, like humidity detectors or motion sensors or anything like that, fill up your breadbox with lots and lots of different types of input devices. You can find those for super cheap. Anything from a little potentiometer and touch pads and all kinds of things. Just fill up your box with them. Spill them out and find what you need to build something cool that takes an input, a human level input. And one cool input device is a LiDAR detector. Like this is the TFLuna LiDAR detector. LiDAR stands for light detection and ranging. It's a remote sensing method that uses a laser. It sends a laser out one side, it receives that laser back in the other side, and based on the time that it takes to receive the laser back, it can tell the distance of objects. And then it can develop a distance map. If you look at some 3D scanners, like if you're going to do photogrammetry, they're often built with LiDAR, which is super cool. They're really cool to use in robotics. So you put them on a robot and you can detect where a wall is or where an object is. If you hook these up into like an Arduino or even right into the Jetson Nano, you can write code that continuously scans an environment. It can tell you where walls are or when some object, like a moving object, moves into a view, and it can display an output, an alarm or something like that, or take an action. It's limited detection, so I think this is like 8 meters, 6 meters or 8 meter detection, far enough for what we needed it for. But if you pay more, of course, you can get a LiDAR sensor that can sense further and at a higher resolution. With all these options that we have available to us, and there's thousands more than what we have here, how do we know what to do with them? Sometimes we're given a concept, and just based on our experience having used these, like I said, you have to go through and play with them and learn how they work. We'll have an idea of the types of products or the types of gadgets that we want to put into a product. And we'll go in and we'll pull some out of the toolbox and see if they fit what we're looking for. Sometimes we just play it by ear, and we'll pick out a couple of pieces and we'll build a small gadget, and then we may pick out a couple more and build some other small gadget and then see how those fit together, almost building block style, like Lego block style. And again, sometimes we just pick a bunch of random parts and try to fit them together and get it to do something. And sometimes it works and sometimes it doesn't. And sometimes we can use an entire concept that we build. And sometimes we build something out and we're like, it's really not fitting a need, or it's really not as cool as we thought it was going to be. But we might come up with a cool little piece of code, a cool way of using one of these little bits and pieces and gadgets that we hadn't thought about before. And we'll make sure we document all of that. And then we just have it in our back pocket for next time. So a lot of it comes down to experience. You buy these things, use them, build stuff. Some of it's going to be great. Some of it's going to be awful. But once you learn how these pieces fit together, it becomes easier and easier to architect some really cool solutions. Well, that's it for today. I hope you found it useful going through some of these gadgets and learning about them and what they're for. Again, go out and buy tons of things, buy tons of stuff, input devices, output devices, controller boards, and just play with them. Put them together into something that works, and it doesn't have to be mind-blowing, it doesn't have to be novel, it doesn't have to be new, but as you learn how each one of these pieces works, it becomes easier to think about how to put them into a larger product. The more you learn about them, the more when you have an idea, you know what to reach for to make that idea come to life. Keep designing, keep creating, and we'll talk to you next time.